Homework 5.8 is on simplifying imaginary and irrational numbers. And there are a bunch of different types of problems, and there aren't a bunch of different examples of each type. So I strongly recommend you make sure you do this homework on your own first, and you're only using this video if you get stuck on ones. And I would pause it after each one you get help on and then try to do the rest yourself, because if you're watching me do an example, then you're not getting the practice on it. And any example you watch me do, and this is the case for all homeworks, you should always go back and then try to do it on your own later without looking at the work you did. So copy it to another paper and make sure you can actually do it. Otherwise, you won't end up knowing how to do it yourself. So I'll go through a few of these and make sure we're all on the same page. Number B, we've got some imaginary numbers. We've got a square root here. And so we need to simplify this. The first thing I notice is that there is this thing inside parentheses. These are not like terms, so I can't combine them, even though they're adding. We have this negative outside, and so that's going to distribute. We get negative 6 plus 7i, minus negative 7 is plus 7, minus I is minus I, plus 8. And at the same time, I'm going to try to simplify this minus square root of negative 36. So I can split this up into the square root of 36 times the square root of negative 1. The square root of 36 is 6. There was a minus sign here. So it's going to be minus 6 times the square root of negative 1 is the definition of I. I is the imaginary number that is the square root of negative 1. So whenever we have a square root of a negative, we want to simplify it into the imaginary number I. Now we have like terms we can combine. So I'm going to combine all these like terms. I'm going to start with the real numbers first. 8 plus 7 is 15, minus 6 is 9. 7 i's minus an I is 6 i's. 6 i's minus 6 i's is 0. So the answer is 0, or is 9 plus 0 i's. If there are no i's left over, we don't write them. In general, if they're real numbers and imaginary numbers, we write it as a plus bi. A real number first, and then real plus an imaginary number. Let's look at number 5, part E. When I look at this, my first thought might be that there are no like terms to combine, but this is actually a bit of an illusion, because anytime there's a power of I that is bigger than 1, here's I to the first power, we can simplify. I squared means the square root of negative 1 squared. And when you square a square root, the squared and the square root cancel out, and so I squared is negative 1. So this is really 6 times negative 1. So we get 5 plus 3i. 6 times negative 1 is minus 6. I to the third can be simplified also. I to the third is I squared times I. And I squared we just saw was negative 1. So we get negative 1 times I. And so I to the third is negative I. So this is negative 8 times negative I, which is plus 8i. The final one is I to the fourth. I to the fourth is I squared times I squared, which is negative 1 times negative 1, which is positive 1. It turns out I to the fourth is just 1. So 10 times 1 is 10. And now we do have like terms. We've got these real numbers. 5 minus 6 plus 10 is 9. And then we've got our imaginary numbers. The 3 i's plus the 8 i's is 11 i's. And as I said before, we write it as a real number plus a real number times I. That's how we can simplify all imaginary numbers. Anything involving imaginary numbers can always be simplified down to something like this. This next one also doesn't look like it has any like terms. You can't combine this into something like square root of 32. That is terrible, terrible math. Don't do that. Instead, what we're going to do is we're going to start by simplifying each of these square roots. We're going to look for a perfect square number that goes into 50 and a perfect square number that goes into 18. A perfect square number that goes into 50 is 25. And so the square root of 50 can be split up into the square root of 25 times the square root of 2. And the reason this is helpful is because the square root of 25 is 5. The square root of 2 can't be simplified, so we get 5 times the square root of 2, which we just write them next to each other and it means multiply. Similarly, there's a square number that goes into 18, square root of 9, and square root of 9 times square root of 2 gives us square root of 18, and we can simplify the square root of 9. There was a negative sign in between here, so we have 3 times the square root of 2. And now we have like terms. This is 5 square roots of 2 minus 3 square roots of 2. And just like if we had 5x minus 3x, we can combine those into 2x's. 5 square roots of 2 minus 3 square roots of 2 is 2 square roots of 2. The last one is I to the 203rd power. And I don't want to use this like long way of splitting it up into a bunch of i's to multiply out. Instead, we're going to use another trick. We saw over here that I to the 4th power is equal to 1. And I to the 203 can be thought of as a whole bunch of I to the 4th powers multiplying together, because when you multiply, you add the exponents. In fact, I'm going to rewrite this as I to the 200th power times I to the 3rd power, because I to the 200th power is just a whole bunch of I to the 4th powers. And I know that because 200 is a multiple of 4. It's 4 times 50. And so this is really I to the 4th power times I to the 4th power times I to the 4th power times I to the 4th power 50 times, or I to the 4th power to the 50th power. We could also use the trick that a power to a power multiplies. And this is all times I to the 3rd. And so I to the 4th power is 1. And 1 to the 50th power is still 1. So we get 1 times I to the 3rd. And we saw earlier that I to the 3rd is one of the special ones. I to the 3rd is negative I. And 1 times negative I is negative I. I to any power will always come out as either I, negative 1, negative I, or 1. So I to any power will be one of these, and in this case, it's what it is. And the shortcut way to do it is to divide whatever this number is by 4, and whatever's left over, that will be the same as the power of I we have. So in this case, I to the 203rd is the same as I to the 3rd, which is negative I. All right. In this next part, we need to multiply. And so when we multiply, we get 30i minus, here when we multiply, we get 10i squared. And just like before, we don't leave powers of I that are greater than 1. This is I squared. So it's the square root of negative 1 squared. I squared, we should know, is equal to negative 1. And so we get negative 10 times negative 1 is positive 10. We usually write the real part first and then the imaginary part last. I'm not going to do this whole one for you, but I will point out that there are 2 ways to do it. One is using our square binomial trick, where we square the first one. We multiply these 2 together and double it, and then we square the last one. That's probably the faster way. Or, of course, you could rewrite it as 2 things multiplying together. What you cannot do is distribute the squaring. That's not a thing. That is not how we square binomials. To give you an example of how to do these, I'm going to do D with you. D, we have a binomial times a binomial. And we know that the first one in the binomial will distribute to both of these. So 2 square root of 3 times 3 square root of 3 is 6 times, all right, 2 square root of 3 times 3 square root of 3. 2 times 3 is 6. And square root of 3 times square root of 3, there's 2 ways to think about it. One way to think about it is that it's the square root of 9. Square root of 3 times square root of 3 is square root of 9. That's a property of square roots. Another way to think about it is that it's the square root of 3 squared. And another property of square roots we have is that squaring and square root cancel each other out. And so it's just 3. Square root of 3 times square root of 3 is 3, which is also what we get when we do square root of 9. Either way, it's going to be 6 times 3, which is 18. That's the first term. The second term is going to multiply out, and we're going to get 2 square root of 3 times negative square root of 5. And so we're going to get 2 times negative 1 is negative 2. We're going to multiply the coefficients. And square root of 3 times square root of 5 is square root of 15. I guess I'll bring it down below. Next, the second term in the binomial is going to distribute. 3 square root of 5 times 3 square root of 3. The coefficients will multiply. And we will get 9 times square root of 5 times square root of 3 is the square root of 15. Using our property of square roots that when you multiply, you can multiply inside the square root. The last thing is we get 3 square root of 5 times negative square root of 5. 3 times negative 1 is negative 3. And square root of 5 times square root of 5, that's that same thing we had before. Square root of 5 times square root of 5 is 5. So we get negative 3 times 5, which is negative 15. I hope we're all seeing that when you do a square root times the same square root, you won't end up with a square root anymore. Square root of 5 times square root of 5 is 5. and so we won't have any square roots there anymore. We can combine like terms. We have 3, and then these are both square roots of 15. So just like before, we have 7 square roots of 15, just like in our earlier example. Okay, and this is our final answer. These cannot be combined because they are not like terms. On the back, we do not leave irrational numbers or imaginary numbers in the denominator. And so we have 2 tricks on how to do this. The first trick is we can multiply by, if it's just a monomial, we can multiply by something that will make it rational. So square root of 3, we want to multiply it times something that will make it rational. And we've been using this trick a lot already, that the square root of 3 times the square root of 3 will just be 3. So if I multiply by square root of 3 in the denominator, I also need to multiply by square root of 3 in the numerator, because this is a fancy way of multiplying by 1, and so it doesn't actually change the value of this number. So we're multiplying by 1 in a fancy way. It won't change the value, but it will make the denominator be 3 now. Here we have a monomial times a binomial, so the monomial will multiply times both. 10 square root of 3 times square root of 3, I hope we're getting used to this by now, square root of 3 times square root of 3 is 3. So 10 times 3 is 30. Notice there are no square roots left anymore when we multiply 10 square root of 3 times square root of 3. On the other hand, when we multiply this one, 9 square root of 5 times square root of 3 is going to be 9 times 1 is 9. Square root of 5 times square root of 3 is square root of 15. And we're not done here, because this is a binomial, both being divided by 3. And since 3 goes into both of these, we can divide. 30 divided by 3 is 10. 9 square root of 15 divided by 3 is 3 square root of 15. So that's our final answer. This next one has an I in the denominator. Let's do this one together. This one has an I in the denominator, and similar to this last one where we couldn't leave a square root in the denominator, we're not going to leave an imaginary number here. So we're going to multiply by I over I. And the reason we're going to do this is because I times I won't be imaginary anymore. I times I is -1. So we get 5I divided by 2 times -1 is -2. We don't leave negative numbers in the denominator either. It's a good middle school trick we should know, or rule we should know. And so we're going to multiply by -1 over -1. That way the denominator will be positive. Now we have a positive number in the denominator, and the numerator will be -5I. We can have a negative in the numerator, just not the denominator. We can have an imaginary number in the numerator, but not in the denominator. And so this is considered simplified. The last one we're going to look at is, what if there's a binomial in the denominator? If there's a binomial in the denominator, there's a trick we can use, which is called multiplying by the conjugate. And this takes advantage of one of the properties of quadratics we've been using a lot, which is that a plus b times a minus b gives us a squared minus b squared. We've used it to factor the difference of 2 squares. We've used it to quickly multiply. And now we're using it to get rid of imaginary numbers or irrational numbers in the denominator. Let's look at how it works. Here we have a minus b. And so we're going to multiply it by the conjugate. If this was negative, we need the conjugate to be positive. So we're going to multiply by 3 plus 2i. If it had been 2 plus square root of 3, we would multiply by 2 minus square root of 3. These are conjugates of each other. We leave the first one alone, and the second one becomes the opposite sign. And if we multiply by this in the denominator, we need to multiply by the same thing in the numerator. That way we're multiplying by a fancy form of 1 that doesn't change the value. Now let's see how we do this. I'm going to start out with the denominator first, because here we have the reason we multiplied by the conjugate. We have a minus b times a plus b, and so it's going to be a squared minus b squared. A squared, 3 times 3 is 9, minus b squared is a little trickier. 2i times 2i is 4i squared. And we'll come back and deal with that in a second. In the numerator, we have a monomial times a binomial, because there's a plus in between these two. That monomial needs to distribute across the plus, and so we get 24i plus 16i squared. Now, we can simplify 2 things here. We don't leave powers of I that are bigger than 1. I squared is -1. And so in the numerator, we get 16 times -1 is -16 plus 24i. And the denominator, negative 1 times negative 4 is going to be positive 4, and 9 plus 4 is 13. This is our answer. Sometimes we can simplify more from here, but in this case, that was it. All right, I hope this helps. Oh, I'll do one more at the bottom. Simplifying solutions to quadratic equations, we're always going to start by simplifying the square root. The square root of negative 100, we're going to split it up into square root of 100 times square root of negative 1. Square root of 100 is a perfect square, so we can simplify it to just 10. 10 times 10 is 100. Square root of negative 1 is I. And so we get negative 10 plus or minus 10i divided by 10. This is a binomial being divided by a monomial, and so we can just divide each one by 10 because 10 goes into both of these. Sometimes we have to do something like divide by 10 over 10, but if it just goes in evenly, you can just straight up divide each of these by 10. Negative 10 divided by 10 is negative 1. Plus or minus 10i divided by 10 is I. So that's an example of how it works. If they all have a common factor, we could also have just divided by what that common factor is. Hopefully that helps in your homework. Good luck on the rest.